Welcome to the Estero Water Resource Center process video series. This is video number 2 out of 5 and overviews the preliminary and primary treatment portions of the plant. Wastewater first reaches Estero by traveling through the underground collection system in the city. 3 main sewer lines direct wastewater into Estero. One collects water from the western sections of the city, one from the northern and central sections of the city, and the third collects from the eastern sections of the city. These 3 lines merge into the plant into one 42-inch pipe that enters our headworks, where the wastewater treatment process begins. For scale, a 42-inch pipe is big enough for a child to stand inside. The location where this line enters the headworks building is the lowest point in the city. All the sewage from the entire city enters right here. The very first treatment step is large object screening. We accomplish this by passing the water through one of 2 bar screens. These are large rotating rakes that remove floating items carried in the wastewater. These screens have removed a whole range of objects within the wastewater, ranging from wooden 2x4s all the way to dolls and dollar bills. We wash the removed objects with fresh water to remove organic material and then compact them before placing into a trash dumpster. Removing these large objects helps to protect equipment downstream. Washing helps to reduce the weight and volume of material we haul to the landfill and produces a more consistent treatment process. After screening, we use a combination of 4 different pumps, 2 250 horsepower pumps and 2 150 horsepower pumps, to transport the water to its highest point within the plant. We use the larger pumps for high flow situations, like our daily late morning peak flow. This peak usually happens around 9 a.m., after the water from people's morning routines make its way to the plant. We use the smaller pumps or low flow situations, like at night when people are sleeping. Flows to the plant vary throughout each day because people use more water when they're awake than when they're asleep. Between these 4 pumps, we achieve a high degree of redundancy for the INFLUENT pump stations, or IPS. Redundancy is especially important in the IPS. If this station were to stop working, we wouldn't have any way to begin our treatment process, and wastewater could back up into the collection system, creating overflows. From the outlet of the IPS, water travels through the treatment process completely by gravity. In fact, from this high point, it travels all the way through the plant to where we discharge the treated water 1.5 miles out in the ocean, without any extra pumping from us. Considering the volume of water we treat, about 6 million gallons a day, this is a pretty amazing electricity and cost-saving feature. From this high point, the water first enters a grit chamber. The grit chamber removes small solids, such as sand, gravel, eggshells, seeds, or coffee grounds. Sand and gravel make their way into the collection system during rainstorms, or when vehicles drive over sewer manholes on the road. All these materials can be very abrasive to our equipment, which is why we remove it at the start of the treatment process. The grit chambers work by slowing the water down and introducing small amounts of air to the water. This air helps to keep the lighter organic material in suspension while still allowing the heavier grit to fall to the bottom. The grit is collected from the bottom of the hoppers and sent to equipment that washes it before hauling to a landfill. This concludes the preliminary treatment process. Now the wastewater is ready to move on to primary treatment. From the grit operations, water passes into one of our 5 primary clarifiers. These long rectangular tanks use gravity and buoyancy as the driving forces to separate the solids from the liquid. The tanks slow down the water, allowing time for light material to float and heavy material to sink. The most important factor in this operation is the amount of time water spends within the tanks, generally between 1.5 to 3 hours, depending on plant influent flow. This residence time determines the speed the water travels, the rate the water flows out of the tanks, and generally how much material will separate in the tanks. A series of scrapers collect the solids. These scrapers run in an ovular pattern along the length of the clarifiers. Think of the scrapers like a big squeegee that helps to move the sinking solids, or sludge along the bottom of the tank, and to move the floating material or scum along the surface of the water. These scrapers direct the scum into a trough on the surface and direct the sludge into hoppers at the end of the tank. We pump both the scum and sludge to our thickening units. These thickening units are precursors to our digesters and are detailed in a later video. The sludge removed within the primary clarifiers is very important to biogas production from our digesters because it's rich in easily degradable nutrients. At the downstream end of the tanks, water exits by passing over the top of a set of weirs. At this point, the water is considered primary clarified effluent, or PCE, and marks the end of the primary treatment process. PCE has substantially less solid material than raw sewage, but still contains suspended and dissolved organic material in it. These materials are hard to remove with sedimentation, so the water moves onto the secondary process, which uses biological treatment to remove the dissolved organics. Estero's secondary process is detailed in video number 3 of this series.